Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. Now, I have a super cool guest for you all today who has an incredible backstory to boot, especially considering I recently read that Python has risen to become the most popular programming language after overtaking Java, which is the first time any language has done that in over 20 years. And today's guest is Peter Wang, and he is a veteran software developer turned co-founder and CEO of a company called Anaconda, which many of you will know brought open source programming language Python to the mainstream for business data analysts. And Anaconda's open source data science solution helps organizations mitigate bias, deploy deep learning models using neural networks, while also predicting numerous current business challenges such as customer churn, consumer demand levels, stock prices, maintenance needs, outage possibilities, and that list goes on and on. So we've got lots to talk about today, and I don't want to reveal any more spoilers. So buckle up and hold on tight as I beam your ears all the way to the US, where Peter Wang, software developer turned co-founder and CEO of Anaconda, is waiting to share his story. So a massive warm welcome to the show. Can you tell the listeners a little about how you got here and ultimately share your origin story with everyone?
Yeah. So origin story, I started actually as a physicist. So my background is in physics, and I was a very happy physics student. But I was in college, I was massively distracted by the internet and by computers. So, and I'd always been into programming since I was, 8 years old. I've been programming computers. And in fact, I almost majored in computer science, but my love of physics was a little bit deeper. So I did that. But once I graduated, I just couldn't. I couldn't resist the appeal. It was 99. It was the height of the .com boom and the internet. And so I went and joined a software company and did a lot of great things there. A lot of fun, but the company unfortunately folded. It was a little startup in computer graphics. But in that time there, I also developed a bit of a passion for the Python programming language, which was just starting to emerge at the time as something very interesting. And so right after that, I went into, I found a consulting job where we took Python and did sort of scientific computing and engineering consulting using Python, which was a great fit for me because as a physicist, I have the mathematical background to understand a lot of the engineering problems, but then to model those things using a combination of C++ and Python, it was a dream come true for me. And so during the 2000s, I guess the aughts, I did a lot of that. But by the end of the aughts, I realized that all of our consulting customers or the biggest ones, the most vigorous ones, let's say, were in finance. And they were using Python not to do engineering simulation or like radar modeling or things like that. They were using Python to do what would traditionally be called business data processing, business data analytics, predictive analytics, right? So they're using Python in lieu of things like SAS or in lieu of traditional, maybe a big internal app written in .NET or Java. They were enabling quants and empowering quants in finance to go and do a bunch of modeling in Python, and they'll bring us in to make the code go a little faster or to build some visualization around the apps that they built. So what we realized was that there's a big opportunity to go and take Python out of the scientific computing niche into a broader data analytics. So I started the company in 2012 with a view to building tools and technologies to empower these, what we called at the time, domain experts, right? People who are not traditional programmers, who didn't have CS degrees, but they had a deep understanding of the domain. They knew the math and they knew the data, but they could just barely express their ideas in Python. So we wanted to build better tools for them to express their ideas and have it run faster, right? Have it run at scale, have them be able to build little apps and deploy them across the enterprise. And so we started the company. And of course, Anaconda was initially called Continuum Analytics. We renamed it Anaconda about halfway through. But our vision for the company, my co-founder and I, it was precisely that. It was to empower sort of everyday business users in whatever domain to better express their quantitative ideas and to be able to iterate faster.
What a great story. A perfect origin story there. Any story that begins with, it started when I was a physicist. It almost sets the scene perfectly. But of course, that path led you to Anaconda, which is the popular Python platform for data science, machine learning, and AI and everything in between.
Mm-hmm.
But can you offer an overview and tell the listeners how you're helping your customers ultimately change the world with tech?
Yeah, well, we have a really interesting open source approach. So we started, we really started with the vision that we would build these products to help people scale compute, like distributed computing, help them deploy applications, all these things. But the odd thing is one of those stories where you end up accidentally building the thing that makes you massively popular, right? Yeah. So we're like, we can't ship any of these massive tools unless we give people an easy way to just get the basic stuff. And at the time, it was still too hard to install basic things like SciPy or Matplotlib, the very popular visualization library. These things are really hard to install, even on Linux, but certainly on Windows, it was near impossible. So we built this little installer with all the libraries pre-built. We put a little package updater in there so people can get the continuing updates that roll out in open source. And we put that little installer out there, and that just took off like wildfire. So now we have hundreds of millions of packages every month that we ship out. We have our monthly data bandwidth is like in the petabytes. So it's a lot that people rely on us to just get the basic pieces of the data science ecosystem. And what makes the numerical computing stack in Python so weird and difficult and hard to install is because so much of it is written in low-level languages like C, C++, Fortran, even some things that are machine, like hand-tuned assembler. So to compile and install all of those in a way that these different packages from different projects will actually work together and not segfault, it takes a bit of art. And no one likes thinking about build compiler tool chains and linkers. Like people hate that stuff. That's why they use Docker, right? Well, the problem is even when you use Docker, you still have to rationalize what goes into the Docker. So this is a problem that doesn't go away. So what Anaconda helps people with is getting just the basic bits all compiled, working together. And there's the added benefit that because we're a company, if you're a business user, you have a vendor you can rely on. So you're not grabbing random bits off the internet, random open source bits off the internet and running it on customer data in a sensitive environment. You can go to a vendor and then you at least check a compliance box and says, yes, I got real bits from a vendor that I'm running on my, in my sensitive environments. So that's how we help customers get the open source they want to run, but also have an understanding of security, really check the boxes on compliance and governance, things like that.
And of course, Anaconda is known for partnering some of the world's largest tech organizations too. And I mean,
right.
a few names off the top of my head here is IBM, Red Hat, Snowflake, AWS, and Intel. So,
and Microsoft.
and Microsoft, yeah. Don't
yes,
forget that.
And also Azure, this little thing called Azure, right?
Oh, that little thing.
Yeah.
But to bring that to life for everyone listening, what kind of problems are you helping these huge tech giants solve?
Well, so it's exactly the same issue. They're finding out that their approach to building and managing traditional, let's say, infrastructure open source software, it's not quite enough to solve the unique built-on tooling challenges of the data science packages. And so data science, machine learning, numerical computing, these require a lot of very, very careful engineering to get the right level of performance and to get the right bits. It's not something that anyone can just go and do. And so what we have here is what's unique about the Anaconda distribution in our build is that it's the same stuff across Windows, Linux, Mac on different architectures. So whether you're using x86 or ARM, Ev1 on Apple, whatever you might be using, we really, really carefully build across all these different platforms. So a data scientist could be doing data science on a Mac. They can go and share a Jupyter Notebook with a colleague that might be on Windows. And then when they find something they want to go and run on some backend Linux servers, whether it's ARM or whether it's x86, they can rest assured that it's the same build, the same package versions, the same everything. And again, it sounds very mundane. It's as mundane as like having clean drinking water, clean electricity, safe food, but it's a fundamental need, right? So we've actually had engineers that some of the biggest companies in the world that rely on machine learning, they've called us sort of the operating system for machine learning, right? We're basically like the electric company, we're a utility because it's such a fundamental need that all these different companies need to have.
And I recently read that Python has overtook Java the first time any language has done so in 20 years. So can you tell me more about how and why Python has risen to become the most popular programming language in the world?
Well, I'll answer that question with the first question. Okay, what do you think? All right, how many software engineers do you think are there on the planet?
Whoa,
all of them. Yeah. All of them.
Yeah.
The ones that write the firmware for your watch, the ones that write the control software for a rocket, the ones that are building all of the open source, the ones that are doing all the infrastructure engineering for the clouds, add them all up. All the hackers, put them all together. How many software engineers are in the world, do you think?
Oh, man, I wouldn't. That is impossible to say.
Well, it's more than a million, probably more than a million. Is it 100 million?
More so, probably.
More than 100 million.
Yeah.
So when I go and read like the IDC estimates and you look at some of these other estimates, people estimate somewhere between 20 to 40 million software engineers in the world.
Wow. And also,
which is a lot.
And there's also
there's
a huge shortage of them as well, isn't there?
Yes, because that is actually like less than 0.5% of the world's population.
Yeah.
Right. So that means in a room of 1,000 something people, you're gonna have 5 or 6 people that are doing the software engineering for everything. You think how much in the world is actually powered by software? Yeah. Everything. I mean, your light switches are powered by software. Your cars have software, right? Everything has software in it, but it's less than 0.5% of the population. And the reason that this question is relevant as an answer to your question is because Python dramatically empowers people who are not traditional software engineers. You have students writing little fun things. You've got, VPs that are doing a little bit of Python coding to do some data analysis. There's people, there's astrophysicists and geneticists, scientists that are definitely not software engineers who are learning to code a little Python to manipulate some data, to visualize some result that came off of one piece of equipment before they massage it and dump it into another analysis tool chain. All these people doing a little bit. There's this huge long tail of people doing things, and they're all just choosing Python. Because it is the saying is the Python is maybe not the best language for everything, but it's almost certainly the second best language for everything. And there's a deep power there. It's like duct tape, right? Duct tape is almost never the perfect solution for any given application. You want a screw, you want to have like a welder, you want all these different things for different applications. But at the end of the day, if you have only one thing, you're just take a roll of duct tape because it basically works for just about everything. You can fix plumbing with it. You can bind some like metal with it. You can do whatever, and then Python is that duct tape. So that's why its massive popularity is not expanding so hard and deep into the core 20 to 40 million software engineers, which it does have a lot of popularity among. Right? Every software engineer is going to be learning a little bit of Python because they're doing some scripting and it's a little bit more pleasant than Bash or Perl. They might want to do some, web API stuff where, a little bit of Python can be quite pleasant to do some of these things in. So everyone knows a little Python, even in the software engineering space, but outside of the software engineering space, where there's literally billions of people who want to touch data, touch their applications, learn a little bit about APIs. They're doing boot camps. They're doing afternoon courses on Coursera and whatnot. They are learning a little bit of Python just to be able to play with things a little bit. And I think that's why there's this adoption momentum.
And of course, another big topic right now, especially as we've moved fast and broken things, is bias that we've unwittingly created in data, AI, and machine learning, especially in black box AI, where it's giving conclusions and nobody knows how or why it created that, it reached that conclusion. So can you tell me a little bit more about why this kind of bias should actually be an enterprise priority right now?
Yeah, it should be an enterprise priority, but I think a lot of the narratives, the concern is well-founded. So let me just say that. The concern is absolutely well-founded. Most of the remediations that I've seen, unfortunately, don't go deep enough. So, it's interesting to note that, for instance, up until, do you know when the Bible was first starting to be printed in English?
Ooh, no, tell me.
Yeah. Well, it certainly was for 1,000 or so years. It was printed in Latin, even though a lot of people didn't, for basically, I think a millennium, it was being printed and it was being read en masse in Latin, even though people couldn't understand it because they were speaking Old English, right? Yeah. And so the problem with that is you empower a priesthood. The priests tell you what the Bible says. You can't read it yourself because you don't read Latin. You show up every Sunday and you get told. And that's the state of AI today, right? Where you have a tiny percentage, that 0.5% that know how to write some code. Of that, 10% can do the machine learning and the stats to do anything approaching what one might call AI. So you have now one person in 1,000, maybe one in 5,000 that can do anything that we call AI. And so even if an enterprise is well-intentioned, an enterprise of 1,000 people will have 1-2 people that really understand AI. And you have hordes of VPs and C-level executives who want to do the right thing with AI. So you've got a little AI tech priesthood. You got everyone else that's just on the receiving end. And once the AI people tell you what it should be or shouldn't be, you ignore them anyway, right? Look at the situation with Zillow, right? Where they absolutely, the data science team was like, I don't think our models are good enough to make these kinds of predictions. But the business went ahead with it anyway. So as long as we create this tech priesthood, we will have all manner of bad things. In the Zillow case, it wasn't a bias where certain groups were being discriminated against and being denied loans or being incarcerated. It was a simple matter of just the business processing, the business data predictions, business data-driven predictions were inaccurate, but the business ignored them because there was this priesthood dynamic. So that's why at Anaconda, we are so focused on this fundamental vision of empowering the world with data literacy. Absolutely. It's literacy. It's literacy that's the issue. It's not, is the AI biased or not? In statistics, if you learn the first thing about statistics, you learn that the fundamental trade-off is bias versus variance. You can go and increase the bias to reduce the variance, or you can set the bias down here and have a massive variance in your outcomes and your predictions. So when we build models, sometimes we want more bias, sometimes we want less bias. It's a tool. It's a machine for creating, for making this bias versus variance trade-off. And so we can never get rid of the bias because that's what the machine is there to do. It takes bias as an input, right? Yeah. So I think the idea here is it's not about making cars safer. It's about getting better drivers, right? And in this case, with these AI, black boxes, all these other kinds of things, there's a really fun thing. We call them black boxes because they're opaque. We can't see through them, right? Yeah. But this is a metaphysical sleight of hand. The opacity or transparency of an object is not really fundamental to the object. It's actually a function of the wavelengths that your eye is sensitive to. A black box may be opaque in the visible spectrum, but it's totally transparent to millimeter wave and to radar, right? Yeah. Whereas a piece of glass would be transparent in the visible spectrum, but if you warm it up enough, it's completely opaque in the infrared. So when we talk about these black boxes, they're only black if you don't have the sensitive enough eyes to see the right spectra to see through the middle of it. And so we're trying to, as a metaphor for literacy, we're trying to get everyone to be able to see into these black boxes, but it has nothing to do with the black box itself. It has everything to do with the eyes of the people doing the looking.
And it often feels like the world is a very uncertain place right now. But on this Daily Tech podcast, I always say technology works best when it brings people together. So can you tell me a little bit more about how Anaconda and the open source community is responding to the current Russian-Ukraine crisis? Because you guys are making big waves here, aren't you?
I agree with you fundamentally. Right? Yeah. Technology is better when it brings people together, but it has to do it artfully. Right? If you do like what Facebook does, which throws 1 billion people into a thunderdome of memetics, then you end up with everyone knives out, and blood everywhere. So literally blood on their hands, right? From certain kinds of disinformation campaigns and genocides in parts of the world. So we can't just bring people together willy-nilly. What technology can help people do is have greater empathy for other people and recognize the common humanity. Right now, when it comes to things like open source, one of the most powerful things that I've seen in open source is that it brings together innovators, like-minded innovators across the world. We have people contributing to our projects from every single country, right? And we have some really powerful people, people who've really powerfully contributed that really can't speak English very well, but they can type really nice things into the code and they can communicate in a written way in GitHub. But that's okay. These technologies bring people together that have shared values. So the open source world is actually much more of a global network than just about anything else. And so then as a global network, we feel the pain when we see the horrible things that are happening in the Ukraine. And there have been calls for us and for others to do more about it, right? Such as trying to cut off access to Russia, things like that. And now as a company, we do comply with legal sanctions and embargoes and things like that. So we do comply with those kinds of things. But to take unilateral action against entire countries, we have to sort of have a bigger conversation as a community, right? And it's not clear. What's really interesting is it's not clear the community is in concordance as to what should be done. Certainly, GitHub doesn't cut off access to people in a country, because there's lots of countries that do bad things. I mean, none quite as egregious as what Russia is doing right now in the genocide and the horrible war crimes that are happening in Ukraine. But when you start getting down that slippery slope, it's like, well, okay, even some of the nice Western countries like to pretend they're all on the right side of history. They do some pretty shady things too, right? Yeah. And so what do we, what's our policy? So I think as a community, we don't have any hard answers yet, but I do think it's good for us to have these conversations, to ask, what are our values as a technology community? There have been some movements, for instance, to try to push for being more sensitive to companies that are doing ESG investments, or like B Corps and things like that. So these conversations are starting to happen, but they're nowhere near settled, unfortunately, at this point in time.
Yeah, completely agree with you and echo your sentiments there. And another topic close to your heart I've been reading about is mentorship. So can you tell me a little bit more about the importance of mentorship, especially in an ever-changing field like data science?
Yeah, well, it's data science, but also software engineering in general. Data science, I would say, has actually more academic grounding than software development. I think a lot of people who are outside of the industry maybe are not aware of the fact that software engineering and software development is quite divorced from the academic discipline of computer science, right? Like there's a lot of things you learn for a computer science degree that don't necessarily get applied in a software engineering context. And most of the problems you encounter in software engineering, you don't really learn about in an academic CS program, because they're human problems. They're problems of complexity. They're problems of design and sort of, to some extent, taste. And all of these things, there's a great quote I heard 20 years ago when I was just starting in the field that said, software is sort of like architecture before the invention of the arch, right? It's people just stacking bricks on top of each other. And because it doesn't fall over, they put another brick on top. There's simply no actual coherent theory as to what makes things stand. And I think that's, unfortunately, 20 years later, still quite true. And the reason for it is because software is so valuable compared to a lack of software, compared to like pen and paper, that you can do really bad software engineering and still add value and still be contributing something. So there's an unfortunate economic sort of perverse incentive where you get paid even if you do a crummy job, because it's still better than nothing, right? And so I think for that reason, because of the economics there, you have a lot of people coming into the industry, throwing stuff at a wall. Some of it sticks and they call it structural, and now it's done. And so that's why mentorship is so important, is because people only learn, essentially it's craftsmen and craftswomen, they learn through painful experience, and they need to pass those learnings down to people who are less experienced than them. Now in data science, what's interesting is that the underlying mathematics and the theoretical frameworks of statistics, data processing, some of these are pretty well baked. But a lot of people flooding into the field don't take the time to learn those things. And certainly they don't learn how to artfully apply them in a business context, where there's a lot more political sort of awareness you need to have. There's a lot more communication skills. Those kinds of soft skills are actually extremely important for data science to be effective in an organization. And those things, again, you don't learn those in school, right? Those are things you have to learn through a apprenticeship, journeyman sort of stage. It is a craft. Both of these things are crafts for different reasons. But that's why I think mentorship is so important. And, like they say, the best way to learn something is to have to go teach it, because then you realize all the things you didn't quite think all the way through when you have to explain to someone else.
And I'm so glad you brought that up, because if anyone browsing through the news feeds and timelines right now will see that many traditional job roles are disappearing, but there is this huge shortage of technical skills. So for anyone that's putting two and two together here, what would you say to that someone that's thinking of learning Python and switching careers, but keep talking themselves out of it because they feel that they're not technical enough? Because there's such a demand for it at the moment. There is a demand for it. I think it's not like an either or. Yeah. I think the best thing is if you have skills and knowledge and business context about a particular area, augment that with your Python knowledge. Learn how to do Python. The best way to learn Python is to learn it while building a solution or building a project, right? Mm-hmm. Don't learn it in a vacuum to go and do some problem you don't care about. Think about problems you care about and ask, how can I learn Python and leverage technologies to make this better? That's almost certainly going to be more profitable for you because it's a hybridization, right? One of the reasons the world is sort of collapsing around us in so much confusion is because we've over-specialized. And as we've learned with whether it's supply chain crises, whether it's academia overproducing PhDs,
everything is over specialized and all the value is in the voids between the specialties. So for those who are thinking about it, I would say there's no better time to start than today and to learn these things, but learn them in the context of the problems you already know about and care about and have a deep amount of experience in. That's you're basically going to be you're building your own little species of unicorn as you bring these things together. It's 2 + 2 = 5 at that point.
Wow, fantastic advice. And we have talked about the uncertainty of the world at the moment, but what excites you about the future? What makes you hopeful?
Well, what makes me hopeful is that there are so many interesting, amazing new technologies coming down the line, and also a lot of insights about human nature, human society. We've made a lot of mistakes in the last 10 or 20 years, but we've also learned a lot, I think. And as sort of the generation, in America, we like to complain a lot about the boomers, right? As the overhang of the the older generations that run a lot of the institutions, as that sort of starts collapsing and the younger generations have to build something new, it's an opportunity to build those new things in a much more holistic, thoughtful, multidisciplinary way. I think hopefully no one of the younger generation believes in sort of just technology will solve everything. I think there is a greater appreciation that technology has to be done in full view and full context of the human condition and the human context in which these technologies are deployed. So I'm hopeful that we are going to be doing much more holistic, thoughtful sort of engineering and technology development cited within the context of a particular human, cultural, human ecological domain. So that's what excites me, is there's tremendous opportunities for building cool new kinds of institutions and ideas.
Incredibly cool. And it's now time for me to have a little bit of fun with you. I'm going to ask you a question I always ask my guests, and that is, can you leave everyone listening with a book that has inspired you, or even a favourite song that we can add to our Spotify playlist? All I ask is you give us a choice and a story behind that choice.
So a book, well, one of my favorite books, for those who haven't read it, is Zen and the Art of Motorcycle Maintenance, which is an oldie but a goodie.
Yeah.
And it might be a little dated now. It was written in the 70s, which is like half a century ago, I guess. But it really explores, I think, the technology, the dichotomy between technology and humanism, and sort of a post-Cartesian approach to the world, which I think is a valuable context for the modern world, as much as it was in the 70s. To some extent, we never resolved some of the things at the heart of what that book talks about. So that's one that keeps coming back to me. And specifically, its sequel, Lila, is quite good, but less read and maybe less appreciated, but goes even deeper into this kind of thing. So that's been pretty influential. And if people want to go really deep and nerd out on stuff, there's a fantastic book called, so it's Deleuze and Guattari. It's called 1,000 Plateaus. I think it has the best commentary, to some extent, most successful commentary on where we find ourselves today in sort of meme land and so many classic cultures and all these things. 1,000 Plateaus is a fantastic book around that.
Awesome. Well, I'll get those added to our Amazon wish list. And before I let you go, for anyone just wanting to find out more information about Anaconda, join your community, contact your team, what's the best starting point for everything?
Well, just go to anaconda.com. That's the place to download the software, to find out what we offer in some of our business and enterprise tiers. Just go there.
Awesome. Well, I'll get that added to the show notes. But more than anything, just a big thank you for sitting down with me today, sharing your origin story that began as a physicist, and all the great work you're doing. Thank you so much, Patrick.
Thank you so much, Neil. Oh, I have a song recommendation for you, though, if you want.
Yes. Yes.
There's a song by Jim White called Drill a Hole in That Substrate and Tell Me What You See, which is a fun little song.
I'm going to add that to our Spotify playlist. Awesome.
Yeah, check it out.
Well, have a great day, Peter. Thank you so much.
Thank you so much, Neil.
Wow, what a great story. And we covered so much in a short amount of time there, such as why bias in data, AI and machine learning should be an enterprise priority right now, the importance of mentorship in an ever-changing field like data science, and how and why Python has risen to become the most popular programming language, overtaking Java. But over to you. We've only just scratched the surface of things in this subject. So I'd love to hear more about your insights, your experiences. If you've got a story to share and you'd like to come on the podcast, I'd love to get that on here too. But that's it for today's episode. So email me, techblogwriter@outlook.com, Twitter, Instagram, LinkedIn, just at Neil C. Hughes, and my website is techblogwriter.co.uk. Now today we've talked about how Python has risen to become the most popular programming language, but what we're going to talk about tomorrow, yep, you guessed it, it's time for me to spin the wheel of misfortune, which will determine what topic we will discuss tomorrow. What's it going to be? Well, I'm afraid for the answer to that, you've got to join me again bright and early tomorrow, so hopefully you will join me. But a big thank you for listening as always, and until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.